This video will cover Chapter 2, Section 1. In this section, we're going to focus on determining the appropriate table, chart, or graph to use for a given analysis, construct and interpret frequency distributions, relative frequency distributions in histograms, and develop and interpret joint frequency distributions. In the videos for this chapter, I will explain which graph should be used in which circumstances and define each graph type. For step-by-step how-tos in Excel and Minitab, go to your Business 101 book, your Business 205 book, the demonstrations that I'll do in class, and the tutorial PowerPoints that you'll find on Moodle. Page 77 has this great illustration that summarizes for you all of the kinds of graphs and charts we're going to make throughout Chapter 2. We'll use these throughout the semester, so we really need to get a good grasp on these kinds of things. And this is a great picture because it breaks the charts and graphs down by data type, quantitative versus qualitative, and data class, cross-sectional versus time series. So we're going to focus for this video on frequency distributions, relative frequency distributions, cumulative, and joint. These can be used for either quantitative or qualitative data. A frequency distribution is a summary of a set of data that displays the number or count or frequency of observations that occur in each of the distribution's distinct categories or classes. It's going to do this in a list or a table. Now, why do we use a frequency distribution? Well, a frequency distribution is a way that we can easily summarize the data. We can condense a lot of raw data down into a very small form that allows us to very quickly figure out what's going on in this data set. What do the data really look like? We'll start off by talking about frequency distributions with discrete data. Recall that discrete data means that there are countable number of possible values that could be returned. The steps to creating a frequency distribution with discrete data really just require us to list out the possible values that might come up and count the number of times that value occurs in our data set. Now, Excel or Minitab will do this count for us. So we have an example here. An advertiser surveys 200 customers and asks them, how many days per week do you read the daily newspaper? The possible responses are 0 days per week, 1, 2, 3, and so on, up to 7 days per week. So it's a countable number of days. The advertiser didn't allow them to say, oh, about 1.5 times a week. So it's discrete data. Using the frequency function, I consolidated that data into this frequency distribution, where we can see 44 people responded that they don't read the paper at all, 30 responded that they read it every day, and then there's a bunch of people obviously in the middle. We often want to know the relative frequency. In other words, the proportion of people or items that fall into each category. That allows us to understand the relative importance of each category or class. To calculate the relative frequency is really easy. So I put here RF for relative frequency. We just take the frequency over the number of items in the sample. So for the first row here, our frequency was 44. 200 people were surveyed. That gives us a number of 0.22, or a relative frequency of 0.22. That's a proportion, so we can talk about it like a percent. 22% of the people in the sample reported that they do not read the newspaper at all. We have this method here that we entitled grouped data. We use this method when we have too many values to list out individually. So certainly this applies to continuous data. Remember, continuous data is data where there are so many values that are possible that we can't count them all. Discrete data can also have many possible outcomes. When we're looking at continuous or discrete data and using grouped data here, we're going to be talking about things like weight, income, age, just to give you a few examples of things that we might create frequency distributions with where we would use grouped data. When we're doing this, we're going to be summarizing the data into groups. So the data really ended up getting organized into classes instead of the individual values like we just saw with the newspaper. Those classes could be things like, when we were talking about the voting example from Chapter 1, age groups. So if we had age groups or age classes, the first class for that voting example would be 18 to 39 years old. The second class would be 40 to 49 years old, and so on. Now, how do we actually develop the frequency distribution for continuous data? The first step is to determine the number of classes, and I'll focus on that more in an upcoming slide. Then we're going to establish how wide each class would be. In other words, what range of values are we going to try to put in here? Determine the class boundaries for each class. So that would be the lower and upper value for each class, determining exactly what numbers could go in the class. And then we're going to determine the frequency, just like we did in the previous example. How many data points fit in each class? All right, so the rules for designing those classes. The number of classes. We've got a general rule of thumb. There should usually be between 5 and 20 classes, depending on how much data we actually have. The book provides you this rule. 2 to the k must be greater than or equal to n. N is our sample size, how many data points we're actually looking at. K is going to be the number of classes that we're breaking our data into. So 2 to the number of classes needs to be greater than or equal to the sample size. And I'll show you exactly how to do that in an example here in just a moment. The classes have to be mutually exclusive. There can't be any overlap, otherwise we'd count a data value in more than one class. The classes also have to be all-inclusive. In other words, for every value in our data set, we need a class to put that in. Classes should be of equal width, so if we decide that each class should be 10 years wide, then we need to make each class 10 years wide. And we also need to do our best to avoid empty categories, though it is possible that we might have to have an empty category depending on the data. So how many classes should we actually have? Well, sometimes determining how many classes to use can require some trial and error. So if you look at my picture here, I have some data on temperatures we're going to look at in just a minute. And I've put these data into too many classes in the first graph. Notice that many of these bars only represent one day in my sample. Well, this is too jaggedy. It's not telling us a lot of information and hasn't really summarized a lot. So this would be too many classes. The bottom graph shows too few classes. It just looks like a couple of rabbit teeth, where half of the temperatures are the one side and half of the temperatures are on the other side, and we don't really see any pattern. So let's do this with an example. Suppose that we have a manufacturer of insulation who randomly selects 20 winter days and records the daily high temperature. They might be doing this to determine what R factor of insulation they should try to be creating. The colder the temperature, the higher the R factor insulation they want to produce. Note that temperature is a continuous variable because it can be measured to any degree of precision. So step 1, we said we need to determine the number of classes. Our sample size is 20. So we need to now find K. K, remember, is going to be the number of classes that we're going to use. That makes 2 to the K greater than N. Or, for this problem, 2 to the K greater than or equal to 20. So I did some math here. 2 to the 4th power is 16. But that's not greater than or equal to 20. So we need more than 4 classes. That 4 that I put to the power there, that was our K, and it's also how many classes. So we need more than 4 classes. 2 to the 5 is 32. Oh, 32 is greater than or equal to 20, so we're going to use 5 for our number of classes. Now, the book will say sort the data from low to high. Really all we need to do is get Excel to give us the min and the max so that we can plug them in this formula below. This formula is going to tell us the minimum class width. We take the maximum value from the data minus the minimum value from the data. That really gives us the range. And then we divide that by the number of classes. So for our temperature example, 58 was the biggest temperature, 12 was the smallest, and we divide by 5 for 5 classes. That gives us 9.2 degrees, but we're going to round that up to 10. So each class is going to be 10 degrees wide. Now, the next part of this is a little bit of an art. For this example, it's pretty easy. I need the first class that I define to hold the value 12 and to be 10 degrees wide. So I chose from 10 to 19.99. That's going to be 10 degrees wide. It's going to contain the minimum value, and it's going to be mutually exclusive from the next class, which is 20 to 29.99, and so on. Then we're going to use the frequency function or the histogram function on the computer to actually summarize this data. So I've gone ahead and done this here. Our class is 10 to under 20. We found 3 in that category. 20 to under 30, we found 6 in that category. You can also calculate the relative frequencies in this table. There are 2 other things we might do with frequency distributions. We might calculate the cumulative frequency distribution. When you hear the word cumulative, you should think add up as we go along. That's what the word cumulative means. So the cumulative frequency distribution displays the number of observations less than or equal to the upper limit of the class, and I'll show you an example in a second. We see again cumulative. Now the word relative pops in here, frequency distribution. So the cumulative relative frequency distribution is a similar kind of thing. It's going to sum up the numbers, but this time it's summing up the proportion of observations less than or equal to the upper limit instead of the number. So this is going to be a fraction or decimal instead of a count. An example of this, here we have an example of discrete data, how many DVD movies someone has checked out, 0 to 3, 4 to 7, and so on. Now this is discrete data. We wouldn't want to list out individually 0 to 31. That would make the table really, really big, and we wouldn't be able to summarize the information that well. So we've got a frequency distribution. The first 2 columns here are the frequency distribution. We've talked about relative frequency, so you see that noted here in the table. Now the 2 new things, cumulative frequency. This number is going to be how many values are less than or equal to the maximum value in the class. So this class contains 60 values. It's the first class. Our cumulative frequency is 60. The next value is going to be the 50 plus 60. How many people have less than or equal to 7 movies rented? 60 plus 50 gives us the 110. And then we add the 47 and so on. The cumulative relative frequency is the same idea, but instead of adding up the count or the frequency, we're adding up the relative frequency. 26% of people fell in the first class. You can see that here. 21% fell in the second class. That means 47.8% or 0.478 fall in the first 2 classes. This is adding up those relative frequencies. The last number better be 1 or we've messed up. In the case of cumulative frequency, the last number better be our total sample size, or again, we've made a mistake. Now what about histograms? You guys did these in your spreadsheets class. Histograms provide a visual representation of that frequency distribution that we've just been talking about. The horizontal axis is these classes or categories. The vertical axis is the frequency. The height of the bars should represent the number of observations that fell into each class. We like to use these histograms because they provide us with an idea about the shape of the distribution. And we'll use histograms a lot in coming chapters. Here's an example of a histogram. All I've done here is graph the temperature data from our previous example. So we see 10 to 19.99, there were 3 items. That's the same thing that we reported in that frequency distribution. Another thing to note here is that because this is continuous data or grouped data, we need to make sure that there are no gaps between the bars. If there was a gap between the bar here, it might indicate that there were no data points that fell into that category. So we have to be careful to slide those bars together. Another thing we might want to do is represent the cumulative relative frequency in a graph. That kind of graph is called an ogive. The green line represents the ogive. It shows no data points less than 10. Then it shows about 15% of the data were in the first data group, and then it adds up the percent of the data that are in the second group to the first group, and so on. Again, this ogive should go all the way up to 1 or 100%. If you're trying to read this, you should be reading it off of the right axis. Excel and Minitab can make this ogive for us. Joint frequency distributions are also very useful. This is really a two-way table or a pivot table that's used to examine data that's characterized by more than one variable. So suppose we were interested in learning something by gender and age. The joint frequency distribution allows us to show that data in a way that we can break it down by two categories or characteristics. You can do this for either quantitative or qualitative variables. The number of rows and the number of columns tell us how many categories there are for each variable. Here's an example of joint frequency. A company offers 3 kinds of extended warranties. Those warranties are sold both online and in store. The company may be interested if buying something in store affects the length of time that the customer will buy the warranty for. You can imagine that in the store you have salespeople and checkout clerks who encourage the customer to buy the extended warranty and to buy the longer extended warranty. And in fact, if we look at this data, we do see people that buy the warranty online tend to buy only the 1-year warranty. Few people will buy the longer warranty. When we're looking at this in store, we have almost equal numbers that buy the 1 and 5-year warranty, and many more that buy the 10-year warranty than buy it online.